Okay, this is Mrs. Robertson and I'm teaching my Math 7 course, and we are doing an Indiana lesson. This lesson is located in your math book after page 334, and it's called it's on page IN1. So if you look at the bottom, it'll say IN1, and this is located after page 334. Has everyone found this in your math book? Yes. All right. So, let's begin. Vocabulary startup. It says, every composite number can be expressed as a product of prime numbers. This is called the prime factorization. A factor tree can be used to find the prime factorization of a number. Now here, your factor trees do not always look alike. I'm going to fill out these boxes, and then I'm going to show you another way to do the problem. So the way the book has it, we have 36. Well, 3 times 12 is 36. Now, 3 is a prime number, so I like to circle my prime number. And I bring it down. 12 is not prime. 3 times what is 12? 3 times 4. Once again, 3 is a prime number. You just keep on bringing it down. 4 is not a prime number. 2 times 2 is 4. So you end up with the prime factorization of 3 times 3 times 2 times 2. Now, we have another way of doing it. Let's complete these boxes. 2 times 18 is 36. Bring the 2's down. 18 is not prime. 2 times 9 is 18. And 9 is not prime. 3 times 3 is 9. Now, we end up at the very end with 2 times 2 times 3 times 3. We'll give you the same answer as this one. You have 2 2's and 2 3's. So, is there another way to find the prime factorization of 36? And yes, there is. And I'm going to show you my way, and I want you to write it down over here. It's not quite as messy, I don't think. So I'm going to start off with 36, and I'm going to say 3 times 12. Now, whenever you use a prime number, just circle the number, and you don't have to carry it down anymore. It's sealed. Now, is 12 a prime number? No. 3 times 4 is 12. I circle the 3. That way you don't have to continue to bring it down like they have on these numbers. 4 is not prime. 2 times 2. So I end up with the same answer of 2 3's and 2 2's multiplying themselves. Any questions on that? I like this way. I think it's neater than the way that they show it over here. Tyler?
I would have brought the 3's down.
You like bringing the 3's down? If you prefer to do that, that is fine. I just like doing it this way. It's not, you don't have as many numbers on. The circles identify the prime numbers. And I just think that it's an easier way of doing it. Okay. It says, if you use different factors, does the prime factorization change? No. If you use here, they use 2 times 18. And this one, they use 3 times 12. But the prime factorization stays the same. So the answer there is no. All right. Now we have the real world link. The test of a hybrid car resulted in 4,840 miles driven using 88 gallons of gas. Find the prime factorization of 88. All right, go ahead everyone, find your prime factorization of 88. I'm going to do it over here. We might do the same, we might do something different. So for the prime factorization on this one, I end up with 2 times 2 times 2 times 11. Now, I want to talk to you about different ways of writing numbers. We might do that later on. Another way to say 2 times 2 times 2 is 2 to the third power times 11. Because when you multiply a number times itself, that's the same thing as writing it to 2 to the third power. Now let's go on to IN2. Powers and exponents. Okay, on this page it says a product of repeated factors can be expressed as a power. That is, using an exponent and a base. So let's talk about the names of these things. Here we have this number. The large number is called the base. The base is the common factor. The little number to the top right is called the exponent. It tells how many times the base is used as a factor. So 2 times 2 times 2 times 2 is written as 2 to the fourth power. Okay? Now let's look at what we have in this chart. Powers are read in a certain way. It says 3 with a 1, that is read 3 to the first power. And the factor, it just has a 3. 3 to the second power, or you could say 3 squared. It means 3 times 3. This is read as 3 to the third power, or 3 cubed. 3 to the fourth power, or 3 to the fourth. And it goes on like that. Those are the different ways. Here we have 3 to the nth power, or 3 to the nth. Okay? So you have, and it shows different ways of writing that. N is a variable, and it represents any number that you want to use. So we will be using variables a lot in this class. So get used to seeing variables as we work our way into equations. Now let's look at the examples. Write 4 times 4 times 4 times 4 times 4 using exponents. That's really easy, 4 to the fifth power. Be careful, always count to make sure you count correctly. It's a shame for you to get this wrong, and because you counted wrong, you put 4 to the sixth power. So always count carefully. This one, you have 3 2s and 2 5s. 2 to the third times 5 to the second. Does everyone know your base and your exponents, what they represent? Okay, now write down the answers to A, B, and C. Write your answers down. Are there any questions on how to get these answers here? It should be an easy thing for you to do. Okay, let's go to IN4. Example 3. Here we have prime factorizations using exponents. You can use a factor tree to find the prime factorization of any composite number. Write repeated factors using exponents. Okay. Now remember, composite numbers have more than 2 factors. What's the name for numbers that have exactly 2 factors? Yes. Composite has more than 2 factors. Prime. Remember, prime numbers, that's why it's prime factorization, have 2 factors. Prime numbers have 2 factors. Composite numbers have more than 2 factors. Okay. So, find the prime factorization of 24. All right, I'm just going to redo it over here. I'm going to do 2 times 12, 2 times 6, 2 times 3. And I will end up with 3 2s and 1 3. So that's 2 to the third times 3. Or you could do it like this. They also ended up with 3 2s and a 3. Okay, let's look at number 4. Find the prime factorization of 120. All right, 120. I'm going to do 12 times 10, just to show you there are different ways of doing it. Neither one of those are prime. 2 times 6. 2 is prime. 2 times 3. 10 will factor down 2 times 5. So I end up with 1, 2, 3 2's, 2 to the third power, times 1, 3, times 1, 5. All right, now I use dots for multiplication instead of X's. All right, now I want you to do D, E, and F. Do your factor trees, and then write the prime factorization. If you need room to do your factor trees, you can do them over here on the right side of your paper. All right. Do those now. So, for 54, you end up with 2 times 3 to the third power. For 125, you end up with 5 to the third power. And for 441, it's 3 to the second times 7 to the second. Are there any questions on how to do these problems? Okay, let's go on to IN4. A county in Indiana has 32 covered bridges. Find the prime factorization of 32 and write the result using exponents. All right, 32, I'm going to use 4 times 8, and I'll still get the same answer. That'll be 2 times 2. 8 is 2 times 4. And I end up with 1, 2, 3, 4, 5. 2 to the 5th power. And that's all you had to do in that. Okay, let's do our guided practice together. What's the answer to problem number 1? Do I have a volunteer to do that one? Aiden?
2 to the 4th power.
2 to the 4th power, very nice. For the second one, yes.
5 to the 3rd power.
5 to the 3rd power. And for number 3, Annabelle, what will our answer be for this one?
6 to the 2nd power is 27 to the 5th power.
Okay. However, it doesn't say prime factorization. We know that the 6 isn't prime, but it doesn't say prime factorization in the directions. It just says to write down the answer, so that's what we did. Now, we have to do the prime factorizations for these problems. So let's do that right now. Now you might have done 4 times an 11. We'll still end up with the same thing here. All right. For this one, it's 2 to the 2nd power times 11. Any questions? I don't have any Kleenexes if you're looking for them. I'm all out. Okay. Do the next problem here. Well, I know 2 divides it. If it ends in an even number, 2 will go into it. Let's see, 2 will go into that again. What, 27 times? That'll be 3 times 9, and 3 times 3. And I've messed up number 7. I'm not really sure if I can read that. We'll find out. So what's the final answer for problem number 5? What did you get for your prime factorization? Violet. 2 to the 2nd times 3 to the 3rd, or 3 to the 3rd times 2 to the 2nd. I like to put them in order, so my base number, the smaller the base number, I put it first when I'm doing this. Okay, 147. 1 plus 4 is 5, and 5 plus 7 is 12, so I know 3 divides it, right?
Yes.
So 3 times 4 times 49. Now, 3 is prime. What times what's 49? Yeah. So we end up with 3 times 7 to the second power. Any questions on that? Okay, let's look at number 7. A house cat can hear sounds as high as 64 kilohertz, while humans can only hear sounds as high as 20 kilohertz. Find the prime factorization of 64 and write the result using exponents. All right, 64's prime factorization. Well, what? 8 times 8 is 64, right? 2 times 4, 2 times 2. So that is 2 times 4, which is 2 times 2. 1, 2, 3, 4, 5, 6. 2 to the 6th power equals 64. All right. How can I write repeated multiplication using powers? Yes.
Let's go 6 times, 6 times, 6 times.
All right. That would do it too. The answer the book has is the repeated factor is the base. The number of times it repeats is the exponent. So let's just use some math words, but it's the same thing that you said. But I have to use math words. The repeated base, practice using our math words, the repeated base, which is the big number, the repeated factor, I should say, the repeated factor is the base, and the number of times is the exponent. The number of times is exponent. All right. Now, what are we going to do for homework tonight? Let's go to IN5. You are going to do all 16 problems on IN5, all. Then, let's turn the page. On IN6, you're going to do 17 to 20. So IN6, 17 to 20. Then let's turn the page. On IN7, you're going to do all. Kids, as you can tell, a lot of these will not take very long to do. You can look at 25 to 29. They're just really quick problems. So let's get busy and do your problems.